All right, welcome to lesson 1.2. Today we're going to talk about gravity. Now what's important to note about gravity is that it's one of the things that impacts us the most every single day and something that we see in our lives every single day. Now in its most simple form, it's the attraction between two masses. So mass 1, mass 2. And when you put these two masses together, they have an automatic pull towards each other, kind of like magnets. And that pull is based on two things. It's going to be based on the masses, or the size, and the distance between those two things. So how big are they, and how far or close apart are they? Now the closer they are, the stronger the pull that they're going to exert. Much like if I was standing 2 feet from someone, it'd be easier to grab them than if I was standing 15 feet from someone. That being said, a bigger object is going to be able to pull harder than a smaller object. So bigger, more gravity; closer, more gravity. Now, in terms of how it was discovered, everyone's heard of Isaac Newton, who's kind of the father of modern gravity. Now, he was sitting under the apple tree. The apple fell. He wanted to know, how did that get there? He is the father of the modern theory of gravity. Now, something that's going to be important for the calculations that we're going to do in class is that gravity, or the acceleration of gravity, is 10 meters per second squared. That means that when things fall through space, that they gain 10 meters per second squared. So they're increasing their velocity by 10 meters per second every second. Now I mention that because in this class we're going to get a brief introduction to physics. So we're going to talk about some important things. One of those is called a free body diagram. And what a free body diagram shows us are all the forces that are acting on a given body. So if we have a mass 1 here, we know that if it's on Earth, we're going to have gravity pushing it down. So the mass is here, gravity is pushing it down. We represent that with an arrow. Now we'll talk more about this in class, but when you have a force pushing down, there has to be a force pushing it up if I'm not moving, so that the overall acceleration is nullified. So there's a normal force by the Earth, just like me standing here, that is pushing me up, keeping me from going through the ground. Now, in class when we build catapults, and in class when we start to investigate further how gravity and how forces work, we're going to look specifically at a few things. There's two equations. One, distance equals velocity times time, and the other is that the potential energy, or E, equals mass times gravity times height. Again, two equations. One involving distance and movement, where d equals distance, v equals velocity, and t equals time, or d equals vt. And the other, where energy equals the mass times the gravity times the height of the object above the surface of the Earth. So energy, mass, gravity, height. We're going to use all of these things in combination to understand how the planets move, why they interact the way they do, and the consequences that it has on the planet Earth.